Okay, a Venn diagram is a way to represent information. So here we're going to have the set U is the numbers 1, 2, 3, 4, and then remember that ellipse means, hey, all the way through 10. And that's the universal set, so that's all the numbers we're representing. Our set A represents the numbers 1, 2, 3, 4, 5. Our set B equals even numbers 2, 4, 6, 8, 10. And we want to list things in the appropriate spot in our Venn diagram. So if we start with A, we're going to have 1. But the problem with 2 is that's actually shared. Both A and B both have a 2. So we put it in the center of the Venn diagram. Then if we go to 3, that's just in set A. 4, once again, it's in both of them, so we put it in the middle. And then 5 is the last one in A that's not in B. If we look at what we have left in B, we've got 6, 8, and 10, and since those are not in A, we just put it on the right side of the Venn diagram. When we talked about this being a universal set, though, we want to ask ourselves, is there any numbers, we kind of label this outside space here, U, for is there any numbers that maybe are not represented in these two circles? So if we start going through, we've got 1 in A, we've got 2 in the middle, we got 3 in A, we got 4 in the middle, we got 5 in A, we got 6 in B. We don't have a 7 listed anywhere, so we put it on the outside to say, hey, this is still part of what we're looking at, but is not in the two sets we're interested in. We've got 8 in B. We also do not have 9 listed anywhere, so that goes on the outside saying, hey, we're still going to look at it, but it's not in either of these sets. And then we've got 10 in B. So that's the Venn diagram that represents these numbers and where they fit in regards to these sets.